right, do you guys have any questions about any of these items on this fraction?
Oh my gosh. It's 20.
Straight lines.
I use rules. I'm still off.
I'm really good at drawing lines.
I would say so. That's
I'm so proud, and you're just like, I can draw a line. I'm pretty good at that. Mine's straight. It's just not
I can
going to
tell
the
like a
dot.
tiny bit of a difference, but that's really good. Yeah. Yay. A little known skill, talent, right? I'm really good at drawing straight lines. I like it. So guys, last chance to ask a question or mention a concern about any of these. If you've got anything like that, I've just given you the answers up there. I guess you're good. Okay. So the
cast was email.
please try number 2. It's up there. Large group. So let's just make sure at least we start off well. We're going to use square roots because there's only, listen please, there's only one squared quantity, so there's really no b, and so I'm going to use square roots. To do this, I need to get the squared quantity by itself, so I'd add 5 to both sides. This gives me x plus 3 squared equals 63. I think just about everybody got there, no problem. And I think just about everybody did the square root of both sides. No problem. Here's where we had issues. There were a lot of folks that wrote this. What's missing at this point? Plus minus needs to be in there right now. So this would be plus or minus root 63 over there. And then I'd subtract the 3 over. This would give me x equals, I would write it like this, maybe negative 3 plus or minus root 63. Those are good solutions, except it said to simplify your answer completely. And so I'd need to break that 63 down. I end up with this, negative 3 plus or minus 3 times the square root of 7. I use maybe a factor tree or something to get those factors in there. That's how that one would finish. The biggest thing that was missing was the plus or minus. Almost everybody did okay without that. All right. Let's try another one. Number 3. The last one was no solution. Let's see if this one has a solution.
Yeah, I know. It makes me try.
Oh, you love it, but it doesn't make me love it so much.
I've kind of titled this first little exercise Explore. So there could be some parts of this, and I'm okay with this. There could be some parts of this first part that you look at it and you don't know, struggle, might be successful, I don't know, maybe you will, maybe you won't be. I'm okay with that struggle right now. I'll certainly make sure that before you leave you've seen at least 1 or 2 examples of good ways to handle this. But I'm wondering if you could pair up with somebody's, and think about some ideas on how you could solve number 1. Okay? So let's take a few minutes and just kind of fiddle around with this. Ready, go. Consider factoring. So let's talk about why you might consider that. I'm sure you noticed this, but I'll point it out anyways. Did you notice that the b wasn't 0? And so the method that we've been using for the past couple of days wouldn't really work here, would it? Because b is not 0. And so I would say, since b is not 0, factoring would be the next viable strategy, right? So let me take you through this. Is there a GCF?
No.
No GCF. That's not a problem typically. Did you guys do this? Did you do a box and say x squared is here, negative 11 is there, my AC is negative 11? There's not that many factors of negative 11, are there? Check it out. Negative 1 times 11 or 1 times negative 11. Isn't that it? Yep. Do either of those work? No, they don't work at all. So walking around, I saw a few folks that wrote this word. Prime, of course, means that it can't be factored any more than it already is. And listen up, but listen to everything I have to say. Don't just listen to the first couple of words. For those that identified that quadratic as being prime, they're right. This quadratic, now listen please, listen. This quadratic cannot be factored. But at least not using nice integer values like we're used to using. Okay? Cannot be factored like that. So where you have arrived at now is this. Now listen carefully. If you can navigate this task, number one, I'd be like really impressed. And number two, it shows that you've developed some really good problem-solving skills. Here's your challenge. Is there any way to take this quadratic, which is prime, which is not factorable in its current form, and is there any way to do some valid math, valid algebra, defendable algebra, to take it from something that is not factorable to something that is? If you can do that, you'll be able to do this. Okay? So take a few more minutes and think about what I just said, what it might mean, and let's think, how could I take something that's prime and do some valid stuff to it and turn it into something that is now factorable, not prime. Okay? So try it. If you can do it, that'd be awesome. A good job with is what are all the tools that I could use to work with a quadratic. So there could be a jeweler's hammer. There could be a sledgehammer. There's a roofing hammer. There's also those awesome pneumatic nailers. You know, those like big nail guns. They're like hooked up to an air compressor that you'd use to like frame a house or something. All you do is you just like hold it up to the thing and you pull the trigger and boom, shoots a nail in there.
Boom. That's what you do.
So, yeah, pneumatic nail gun. Pneumatic nail gun shoots air, nail. I've built houses before and I stop and think sometimes, if I had to use just a regular old hammer and nails, I can't imagine how long this would take. With a nail gun, it's just like bam, 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 3 nails in, just like that. They are. But you got to put the ear things on. So guys, listen up. Hey, listen. My point with saying all that stuff about hammers and nails is you need to know what the right tool for the job is. You would never use a nail gun to build like a picture frame. Not like a big nail gun, at least, right? You would like destroy the wood. And it'd be, I guess if you're going for a certain look, you could, but I just, like, a messed up picture frame, right? Yeah. So guys, here's the deal. I wanted you to go through that potentially frustrating experience of, gosh, I don't know what to do. All of the tools that I've been given up to this point, none of them worked. I tried this, didn't work. I tried that, it didn't work. So maybe there's another tool that you need to buy, put in your toolbox, and bring with you. Does that make sense? Mm-hmm. So like I said to you guys before, the idea is that we have a quadratic that is not factorable. We want to turn this into a quadratic that is factorable. Here's how you do it. So if you ever run into this, like I said, literally, like if you ever run into this, you're like, I don't have the tools for this. This is a tool that works really, really well. And we're going to look at one more beyond this. Here we go. Step number 1. Take your C and add it to the other side. What's my C right now? Negative 11. So I'm going to add that to the other side. That's going to give me this. Listen, please. There's a couple of pretty intricate steps. So if you add the C or subtract the C as appropriate, you take it to the other side, right?
This is if the C is prime or if any of the numbers are prime.
Shh. This is if you can't factor it.
Okay.
So the C may or may not be prime, the B may or may not be prime, same thing with the A. The idea is if the whole quadratic isn't factorable, this would be a new tool for your toolbox that you could use.
Okay.
So here's the deal. Earlier I said we want to take something that is not factorable and make it factorable. Because if we could, we're all good at factoring now. We could actually do this if we could just create a factoring, something that's able to be factored. So there is a special number that needs to be inserted right there in order to make this a very nicely factorable quadratic. So 0, that would work, but it's not the special number. 1 is a special number, but it's not this special number. And we could proceed 4, no, 5, no, 6. I'm wondering, would you like to explain?
23.
If you don't want to, that's okay. Hey, listen. Victoria, explain what you were thinking.
I took the b or 8 and then you divide it by 2, so you get 4, and then you square it and you have 16.
Now, she said that really well, but she said it pretty fast. She explained that really well. Here's how you get this special number. The way you get that special number, I need that to go away. Whatever. Hey guys, listen. The way that you get that special number is you identify your b. Shh. Boys that are just chatting, you're going to be so lost because you weren't paying attention. It's going to be sad. Jaden, stop giggling. Just listen. Identify your b as 8. Victoria said this well. Then what do you do with the 8, Victoria?
Divide it by 2.
Divide it by 2, and what do you get?
4.
4, and then you take that and you square it. So half of b is 4, and then 4 squared is 16. So if you take your b and you cut it in half, and then you square it, that will always give you your special number. So here we go. My special number is plus 16. Now, if you are savvy, you know you can't just do that. You can't just say, hey, I would like to throw a 16 on one side of the equation and call it good. What do you have to do to balance that?
Put it on the other side.
You have to add it to the other side. That's right. So notice what I've done. I've added 16 to the left side, and I've added 16 to the right side. So have I messed with the balance of this equation?
Yes.
No.
I have not messed with the balance at all. I've changed the form, but I haven't messed with the balance of the equation. So what I have done now is I've taken something that was not factorable, and I've turned it into a very special factoring because I found my special number, 16. The right side, of course, is 27. Does anybody know how the left side factors? The left side definitely factors now. If you need to scratch some work out, that's fine. Say again? Go ahead and factor it. Yeah. Do I do what? If I do that, I would undo all the work I just did. So don't do that. Just look at the left side. Guys, a few minutes ago I said you're really good at factoring, and that's true. Go ahead and factor. Factor the left side. Got it, Nick? What are you confused about?
Wait, so do we just factor?
All I want you to do is look at this and factor it.
Okay.
Use your box, use whatever you want,
Okay.
and factor the left side. Remember, we had something that was not factorable, and we found that special number, the 16. And by adding that in there to both sides, now I've got something on the left side that's factorable.
I got it answer.
What do you got?
X plus 4 times X plus 4.
Hey guys, listen up.
Pew, pew,
Hey,
pew.
guys. Coy's got it. Hopefully the rest of you do too. The left side factors like this.
Only Carter can see.
Shh. Quiet down. What numbers multiply to be 16 and add to be 8? It's 4 and 4, isn't it? Would you agree with me that I could also write this like this? This is a key. Haven't you seen something like this before? Like a half hour ago? If I want to solve for x, what do? Square root. So I square root this side. I square root that side. I get x plus 4 equals plus or minus.
3 root 3.
We'll get there. My final step would be to come over here and subtract the 4. X equals negative 4. Plus or minus root 27. Please don't pack up yet. Stop. Please. Please don't pack up. You'd end up with this answer here, negative 4 plus or minus 3 root 3. There are a few other little tips and tricks we can go over, and we'll do that tomorrow. But I wanted to leave you with this. This process has a name. Here it is. I didn't want to tell you this name at the start. I just wanted to explore. This process is called complete the square. The reason why it's called that is because you're taking something that wasn't factorable and you're completing it so that it is now factorable. Basically is what you're doing. So anyways, have a great day. See you tomorrow.
Wait, Brian, did you bring
Okay.